Hi everyone, welcome back. Today we're diving into Group 2 of the periodic table, also known as the alkaline earth metals. By the end of this video, you'll learn the elements in Group 2, understand their common properties, and the important trends that explain how they behave in chemical reactions. Let's get started. Group 2 elements are located in the second column of the periodic table. They include beryllium, magnesium, calcium, strontium, barium, and radium. They are called alkaline earth metals because their oxides and hydroxides are alkaline in nature and were first discovered in the Earth's crust. All Group 2 elements share some common properties. They are shiny metals with relatively low densities. They are good conductors of heat and electricity. They all have 2 electrons in their outermost shell, which makes them form 2+ ions in chemical reactions. They are less reactive than Group 1 metals, but still reactive compared to many other elements. Now let's explore the important trends as we move down Group 2. The atomic radius is the distance from the nucleus of an atom to the outermost electron. Think of it as the size of the atom. As we go down the group, the atomic radius increases. This happens because each new element has an extra electron shell, making the atom larger. Shielding effect happens when the inner electrons block some of the attractive force of the positively charged nucleus from reaching the outer electrons. With more shells as we go down the group, there's a greater shielding effect. More inner electrons block the attractive pull of the nucleus on the outermost electrons, making it easier to remove them. The nuclear charge, or number of protons, also increases as we move down. But this stronger positive pull is outweighed by the increased distance and shielding. All Group 2 elements lose 2 outer electrons to form ions with a 2+ charge. Down the group, the ionization energy decreases. Less energy is required to remove the valence electron, meaning it becomes easier to remove those electrons. Now let's look at how these metals react with oxygen, water, and hydrochloric acid. Group 2 metals react with oxygen to form metal oxides. For example, 2Mg plus O2 produces 2MgO. Magnesium burns with a bright white flame, while the reaction becomes even more vigorous as you go down the group. Each metal burns with a different colored flame. Calcium produces a brick red flame. Strontium emits a crimson red flame, and barium gives off an apple green flame. Because of their distinct colored flames, these elements are commonly used in firework displays. With water, reactivity also increases down the group. Magnesium reacts very slowly with cold water, but calcium reacts faster, and strontium and barium react even more vigorously, producing metal hydroxides and hydrogen gas. The general reaction is metal M plus 2H2O to give the metal hydroxide, MOH2 and H2 gas. Group 2 metals also react with dilute hydrochloric acid to produce metal chlorides and hydrogen gas. For example, Mg plus 2HCl produces MgCl2 plus H2. And just like with oxygen and water, the reaction becomes more vigorous as you go down the group. So, let's summarize the trends in Group 2. Atomic radius increases down the group. Shielding also increases down the group, weakening attraction to outer electrons. The effective nuclear charge therefore decreases. As a result, ionization energy decreases, so outer electrons are lost more easily. Reactivity increases as we go down Group 2. We observe this in the reactions with oxygen, water, and hydrochloric acid, which all become more vigorous lower in the group. And that's Group 2, the alkaline earth metals. Their predictable trends make them a great example of how the periodic table helps us understand chemical behavior. If you found this lesson helpful, give this video a thumbs up, share it with your friends, and subscribe for more chemistry made easy. See you in the next video.